So I will show you the work I do on detecting polymorphic shellcode.
That's going to be badass. You said that in perfect English, too. Polymorphic shellcode, I like that.
So this is the 3 points of my presentation, my talk. So firstly, I will tell you why I did this. I did this work. Then I will talk about it and explain you on an example, which is the boxer encoder. Firstly, some vocabulary. So a shellcode is a binary we use on when we exploit a vulnerability on a program. Then the exploit will execute the shellcode on
the host.
Okay, so polymorphic shellcode is encrypted shellcode, and when it's executed, is firstly decoded, and before being executed on the machine. That's why we call it polymorphic, because it's self-modifying. Then dynamic analysis. It's
Emulation.
yeah, but based on emulation, and then we analyze the result to determine if it's a shellcode or not. And there is also static analysis, which only perform operations on the binary. It doesn't need any execution. So, detecting polymorphic shellcode is still a problem. So actually, the more used method.
The most common method?
Thank you. Used is dynamic analysis. It's good for detecting shellcode, but the time of execution is quite bad. If you have heard about Unicorn, which is an emulator which is available since some days. So I tried it. I used a script on which use Unicorn to emulate shellcode without handling syscalls and without doing any analysis with the results. And this is the time I get for the emulation only, so more than 1 millisecond. And so it's not a bad result, but we can't only use it for detection. It's not...
We cannot rely on it, basically on fast processing. On fast processing.
So I made a method on based on static analysis. So to do it, we have to study algorithm of common encoders, so like boxer of everyone who can find on Metasploit, for example. So we have to study algorithm and then we can build a process to detect and decode polymorphic shellcode. Sorry. Like this, we have 0% rate of false false positive.
Yeah, false positives. Yeah.
And yeah. Du coup, je sais plus ce que je dois dire chaque fois. Okay, so in particle, firstly we use an IDS.
Yeah, an IDS,
Yeah.
like sorry, Kata,
For example.
for example.
So we use signature or PCR array to filter the packets on the network, and then we extract as a binary the packets the others. So, and we send it to the analyzer, which will confirm the encoder and will decode the shellcode after this. Then once the shellcode is decoded for the first time, I send it back to the analyzer so that we can handle multi-encoded shellcode. So, for example, with the boxer encoder, you can find on Metasploit. So the to encode a shellcode, firstly it generates an IV of two bytes, and then it encodes the two first bytes of the shellcode, XORing it with the IV. Then every other the 2 bytes of the shellcode are XORed with the previous two bytes already encoded. Then a decoder is put before the shellcode, so that when it executed, the decoder decodes the shellcode and then execute it. So the decoder is contain 12 steps. I don't know.
Good.
No, so okay.
I try to bargain.
So these steps are metamorphic. That means they have we can write it they have many different forms. So we have firstly get PC to get the position of the shellcode on the memory. Then we have initialization of the variables, like the number of loops we have to do to decode, and then the loops for decode the shellcode. Okay. So all my analyzer works. Then so firstly I had to understand the decoder, so to understand how it works and all the forms it can have. Then I could build the processes, which firstly find the 12 steps, verify they are true steps. For example, if the registers are correctly used, or things like it, and then it decodes the shellcode. Okay. So some results about it. So firstly, I come back on the unicorn time to emulate the shellcode encoded by Bloxer. And then the time used by my analyzer to detect it and decode entirely the shellcode. So the only step Bloxer is for detect and decode. Others is initialization and output. So yeah, c'est microseconds. Then we can say static analysis is really faster than a dynamic one. Yeah, we have all the information about the encoders, or the encoder, it depends. Like its name and potential options. And also we have 0% false positive. But for this method, we have to know the algorithm of the encoder. We have to study it, and then it's so we have a non-null false negative rate. Moreover, we have to look at
we have to stay aware of the possible modification of the algorithms.
Thank you. Okay. So to finish, I can say we can't. We have already to use dynamic analysis because we can't know about every encoders that can exist. But in a real life, okay, ouais. The majority of the shellcode we can, the polymorphic shellcode we can find on a network, encoded by a common encoder. So using this type of analysis of static analysis is
Mandatory.
Mandatory for an IDS, a good IDS.
You made it! Yeah!